Hello everyone, welcome to Dakshana e-classroom program. So I hope everyone did their best in DT05 NEET exam, and let me discuss the solution for part physics. So we're starting with question number 1. A ball is dropped freely while another is thrown vertically downward with initial velocity v from the same point simultaneously. After t seconds they are separated by a distance of. So it's question number 1. It's saying like from some point one ball is dropped, means initial velocity 0, acceleration is g downward. Another ball is simultaneously thrown with initial speed u equal to v, and again acceleration a will be equal to g also downward. Now it's asking the separation between them. So let's say I will say this is ball 1, this is ball 2. So relative velocity of ball like say 1 with respect to 2, ball 2 with respect to 1, it will be simply equal to v, and relative acceleration of 2 with respect to 1, it will be 0 because both are downward. Then relatives acceleration are relatively it's like uniform velocity motion or uniform motion. So the separation between them is given by simply v into 2t. This will be the answer that is matching with option 3. Question number 2. The average velocity of freely falling body is numerically equal to half of the acceleration due to gravity. So it's saying freely falling body. So let's say one body is drawn, so initial velocity 0, acceleration is equal to g, and its average velocity for some time it's given as v average, it's given as g by 2 numerically, right? And acceleration due to gravity, the velocity of the body as it reaches the ground. So acceleration we already know, it's g. Let's calculate the time, how much it is taking. So if let's say t is the time taken, then what I can write, displacement is equal to half gt square. Then what is v average? V average will be equal to s divided by time, that is equal to gt square by 2 divided by t, that is this, and this is given as g by 2. Right? So tt gets cancelled and this gets cancelled, gg gets cancelled. This implies time taken is equal to what? This is equal to 1 second. So the actually body has taken a time of 1 second to fall, right? Then velocity, final velocity is equal to what? 0 initial plus acceleration is g into t is 1 second. So v is coming out to be simply equal to g. That's the answer. Question number that is matching with option 1. Next, question number 3. Two bodies of different masses are dropped simultaneously from top of tower. So two bodies, let's say this is some tower, two bodies are dropped of different masses, m1, m2, dropped from top of the tower. Okay, if air resistance is proportional to the masses of body, so air resistance F air, I will say directly proportional to the mass of the body, then the heavier body reaches the ground earlier. Now options are given, we need to check the correct one. So the lighter body reaches the ground earlier, both the bodies reaches the ground simultaneously, cannot be decided. Two bodies of different masses are dropped simultaneously from the top of the tower if the air resistance is proportional to. So here what we can write, actually acceleration is given by mg minus, let's say this is air resistance is proportional to mass. Okay, so I can write some constant k, then I can write air resistance is equal to what? K into m. So let's say then net force will be acceleration will be mg downward force minus air resistance divided by mass. So you can check, it's basically coming out to be g minus k. It's not depending on the mass of the body, so that means both the bodies will be reaching the ground simultaneously. Third one will be the right answer. Next, question number 4. Man standing in a lift falling under gravity releases a ball from his hand. Man, this is a standing in a lift, okay, falling under gravity means the acceleration of this lift is equal to what? G, and the man will be also equal to g. Releases a ball from his hand, as seen by him the ball. So now what is happening, like the man is falling with g, and if he is holding one ball, let's say, and he is releasing, so then relative acceleration of both the bodies will be like what? 0, and whatever the like velocity the man is having when he is releasing the ball, exactly same velocity will be there of ball with respect to ground frame. So if I look at it from this frame, then both will have initial relative acceleration 0, relative velocity 0. So simply even after releasing the ball, it will not move relative to the person standing or release. So the fall down, then the as seen by him, the ball fall down, goes up, execute SHM, remains stationary relative to the person. That will be the correct statement. A particle is dropped from rest a large height. Assume g to be constant throughout the motion. Time taken by it to fall through a successive distance of 1 meter each. Here for question number 5, acceleration due to gravity, it's taken as g and initial velocity is 0 because it's falling, and then we can write s is equal to what? Half gt square. So you can write actually the time taken for, let's say, 1 meter, then it will be like t is coming out to be under root 2 into s divided by g, is it? So time for 1 second, like first 1 meter, so let's say t1 is equal to what? Under root 2 by g. Time for second 2 meter, total 2 meter, this will be equal to under root 4 by g, and time for third, it will be under root 6 by g, and similarly so on. Now it's saying this is the time taken to travel 1 meter, time taken to travel 2 meter, time taken to travel 3 meter, and so on. I can write time taken to travel n meter, this is 2n by g. Now it's saying duration of time taken to travel first 1 meter, second 1 meter, so that will be equal to duration, let's say, let me write it t1 prime, that will be equal to what? Simply root that will be equal to simply under root g 2 by g, and then time taken to travel next 1 meter, means if the body is falling from here, let's say this is the 1 meter, then time taken is 1 prime, then it's 0 to 2 meter, let's say it's taking total t time, but it's asking this 1 meter how much, that I'm writing t2 prime. So this t2 prime will be equal to under root 4 by g minus under root 2 by g. So this is equal to under root 2 by g root 2 minus 1. Similarly, next time taken to third 1 meter, so let's say 0 to 3 meter, we know the total time is this, but 2 to 3 meter, that will be the 1 meter. So for this 1 meter, the duration taken is, let's say, t3 prime, then I can write t3 prime will be equal to under root 6 by g minus under root 4 by g, and that will be under root 2 by g, and this will be equal to root 3 minus root 2. So if I just take the ratio, then it comes out to be like this is simply gone, it's 1 is to root 2 minus 1 is to root 3 minus root 2, and so on. So that matches. You can write this ratio of time taken to travel a successive distance of 1 meter, that will be like root 1 ratio root 2 minus 1 is to root 3 minus root 2 is to similarly root 4 minus root 3, and so on, and root n minus root n minus 1. This will be, so that matches with option third for question number, this is 5. Next, let's see. Okay, next question number 6. So the displacement time graph for two bodies A and B are OP and OQ respectively, and their angle, this is 60 degree and 45 degree, ratio of the velocity of B, and so we know actually velocity is equal to slope, and that will be equal to what? Tan 60 degree. For A and VB will be equal to again slope, that will be equal to tan of 45 degree. So this will be root 3 divided by 1 will be the ratio, that matches with option 2. Next question number 7. The position time graph for two children A and B returning from their school to their homes P and Q respectively are shown in the figure. Choose the correct entries in the given below. So here P and Q, here diagram is not looking proper. This is A, this is B. If I'm taking this is A, this is B. So then A live closer to, and about their schools, like no proper information is given. So actually like here the diagram is not sufficiently clear, and information is also not clear. So you will be provided actually like this is a bonus question. Actually some error is there in the question. Data is not sufficient, actually you can call it. A body move with velocity 3 meter per second due east and then turn due north. So initial velocity 3 meter per second due east, then turn 3 meter per second due north, and the time taken is 6 seconds. So then acceleration is equal to what? Final velocity minus initial velocity minus. So final velocity minus of initial means this, it will be in this direction, and that is equal to so 3, and this is minus 3. So the magnitude of this will be 3 root 2, and the acceleration, this change in velocity is equal to 3 root 2. Then acceleration is equal to 3 root 2 divided by 6. That comes out to be 1 by root 2 meter per second square, and direction will be this way, and that we can check towards north west. Yes, and towards north. Okay, it will be like matching with only option 2. So next question number 9. Two cars are traveling towards each other on a straight road at velocities of this and this respectively when they are, so two cars traveling on a straight road A and B, and their velocity 15 meter per second, this is traveling 16 meter per second towards each other respectively. They are 150 meter apart, 150 meter apart. Both drivers apply the brake and the car decelerate at, so this decelerate at acceleration, let's say, I mean like negative acceleration, A is equal to minus 3 meter per second square, and this side A is equal to minus 4 meter per second square. So both decelerate, then until they stop. Separation between the cars when they come to rest. One way we can go is that like initial velocity, let's check when how much distance it is traveling before final velocity is becoming to 0, so that we can write it initial final velocity 0 minus 15 square is equal to minus 2 into acceleration 3 into displacement. So this is coming out to be S1 is equal to how much? 15 into 15 divided by 3 into 2. This is 575 by 2 75. So that is 7.5 meter. So means this car is traveling this much distance before coming to rest. Similarly for B car, I can write SB is equal to, by simply this is 16 multiplied by 16 divided by 4 multiplied by 2, and that will be equal to 232 meter. So total distance traveled is basically adding these two, so it's 67.5, and 150 minus 67.5, this is 150 minus this is 0.5 and 9, this is matches. Right, let me just check the calculation part properly. So this is final velocity is becoming 0, so then it's like v square minus u square is equal to 2as that we are applying, and this is 3 is 15, okay, 37.5, and here initial velocity is given as 16 meter per second, and the acceleration is until they stop. Okay, so v square minus u square again, so 16 into 16 divided by 2a, so this into this, or this is 4, 2 and 32, that's correct actually. So we are getting 67, and if I write it let's say okay 70, then it's 80, 82.5 should be the separation between the car when they come to the rest. So here no option is matching. Let me just check the calculation. Okay, there was one small, so if adding it will be 69.5, then 150 minus 69.5, that will comes out to be 80.5 meter. So this will be the separation between the car when they finally comes to rest. That is the like option, fourth one for answer for question number 9. Next question number 10. A point move in straight line so that displacement x meter at a time t second is such that, so question number 10, here t is mentioned as this is x square minus 1 power half, so squaring both sides, t square is equal to x square minus 1, and this implies x square is equal to t square plus 1. Okay, so this is all given. Now it's saying the separation, okay, its acceleration in meter per second time per second at t time second is given as, so we need to find its acceleration. So first differentiating it, then we will get so this is 2x v velocity dx by dt will be equal to 2t, so this implies x v is equal to what? T by x. Okay, and then differentiating it again or both sides, so this is 2 gets cancelled, this is x v is equal to t, so this is v square minus this is differentiation of x, then it's v square minus x into a equal to 1. Okay, so then we need actually here acceleration. So v square minus 1 is equal to xa, and that implies a is equal to v square minus 1 divided by x. This is the expression, but we need to express that only in terms of x. So the c v square, we got this, so let me substitute it. So a is coming out to be t square by x square minus 1 by x, then it will be t square minus x square by x cube, and now t square minus x square. So from here t square minus x square is equal to 1, so that means it's coming out to be 1 by x cube is the acceleration of particle. Let me just explain it. This is the original relation given to us. Rearranging it, we are getting it this, and then x square is equal to this. Differentiating it with respect to time, then we are getting this, and velocity is coming out to be t by x. So just rearranging it, this is, then differentiating again. So differentiation of x with respect to t will be v multiplied by v will be v square, and one more thing, it will be like plus actually. So then differentiation of x and differentiation of v will be a. So then we are getting it this, and then just rearranging it, this will be right xa. Let me just check it up to here, it's correct. So this is xa equal to, this is 1 minus v square, and this will be 1 minus v square by x, and substituting it, it will come 1 minus t square by x square, and this is x square, it will finally x square minus t square by x cube, and x square minus t square, so x square, yes, that will be equal to 1 actually. So finally we are getting it 1 by x cube. That will be the second answer, matching correctly for question number 10. Next, question number 11. So here a ball is dropped vertically from height h above the ground. It hits the ground and bounces up vertically to a height h by 2. Neglecting subsequent motion and air resistance, its velocity v varies with height h. So let's see here. So this is the top. From here some ball is dropped. Let's say it is at height h and velocity v, and acceleration I am taking it g. Then we know the relation is v square minus initial velocity g square is equal to, I am taking downward as positive. Basically I need to take downward as negative here, so it's okay, I will take that direction simply. Let me write the magnitude, then it's 2 into a acceleration g into height h. So first thing is the relation between v and h, it's a parabolic, it will not be a straight line because v square is equal to 2gh. Okay, another thing, if we are taking the downward direction as negative, then the velocity will keep initially when it is at height h, velocity will be 0. This is v versus h graph, and as it's going down, h will be decreasing, velocity will be increasing but negative, and it will be like parabolic, so it will be something like this. So finally it's striking the ground, h becoming 0, velocity will becoming minus, and that to maximum. Now it's bouncing back, so it will be bouncing with maximum velocity, but because it's not jumping to the same height, so means the velocity, the collision is not perfectly elastic, it will be bouncing back with the less velocity. So velocity immediately after like when it's bouncing, it will become positive. Okay, then as it's moving up, velocity will keep on decreasing and it will be finally reaching. So this will be the graph matching perfectly, so that is matching with option 1. Question number 12. A and B are two trains moving parallel to each other. Okay, if a ball is thrown vertically up, so let's say question number 12, so this is a train A and another train B moving parallelly, and a ball is thrown vertically up from the train A. So from here a ball is thrown vertically up, like this is from ball thrown vertically upward from train A, that is with respect to frame of train A. Okay, and it's moving, let's say some velocity VA, let's say velocity VB. From this train A, the path of the ball is parabola for an observer standing on the ground. Now see, for an observer standing on the ground, the ball will have velocity, because when we are seeing it from this frame, then it's thrown vertically upward, but when it's throwing vertically upward, the velocity of train will be also imparted to the ball horizontally. So the net velocity of ball will be like vertically and horizontally will be in this direction, and then you can see the motion of the ball will be parabola. So statement 1 is correct for this person standing on the ground. Next, vertical straight line for an observer B when B is moving with same speed in same direction of A. Now see, when VA is equal to VB, then what will happen actually? For a person sitting in B also, the relative horizontal velocity will cancel out for the train and for ball also. So for this person also, it will appear that the ball is given only vertically upward velocity. So what will happen? It will go up to some height and then fall back when this is the condition. So that means a vertical straight line for an observer B in B when B is moving with same speed in the same direction. So that is also like second statement is also seems correct. A parabola for an observer in B when B is moving with same speed but in opposite direction. Now see, if B is moving with same speed V but in opposite direction, then what will happen? Net velocity of this ball with respect to this person will be basically even 2V in this direction and this. So net velocity in this, so again the path will be parabola. It will appear that the ball has thrown at some angle when observer sitting in B is observing this ball where train is moving backward with same speed. So in that case, third is also correct option and fourth is all of the above are true. So that is right statement. Next, question number 13. Okay, so a body start with initial velocity. Question number 13. Body start with initial velocity. So initial velocity is given as 2i cap 3j cap plus 11k cap. This is the initial velocity, and move with an acceleration. So acceleration is given as 5i cap plus 5j cap minus 5k cap. This is the acceleration. What is its velocity after 2 seconds? So that is simple. V is equal to u plus at, right? V bar. So this is equal to 2i cap plus 3j cap plus 11k cap plus 0.5. Time is taken as 0.2 second multiplied by, this is a into t. So this is 5i cap, 5j cap, 5k cap. Multiplying it, what it will be? This is 2i cap, 3j cap, 11k cap, and this on multiplying it will be like yes, everything correct. 2 into 5 it will be 1 I cap plus j cap and minus k cap. Now simplifying it, 2 and 1 it's 3 I cap, 3 plus 1 4 j cap, 11 minus 1 so 10 k cap. That will be the final velocity, and which option matches with like force. This is question number 13. Next, question number 14. Find the speed of two objects if when they move uniformly toward each other they get 4 meters closer each second. That means, let's say the velocity is VA and VB is the velocity of two objects. So when they are moving closer towards each other, then relative velocity will be equal to what? VA plus VB, and with that they are coming closer by 4 meters per second. That means the relative velocity is equal to 4 meters per second. Next case, when they move uniformly in same direction with the original speed, they get meter closer each other. So that means if I say, let's say VA is greater than VB, then VA minus VB, when they are moving in same direction but still they are getting closer, so means the speed of one should be higher, and but now it's like getting closer by 4 meter in 10 seconds. So in 1 second it's basically 0.4 meter in 1 second basically. So this is the relative velocity in second condition. Now we are asked to find speeds. So simply adding these two, then VA we will be getting these two divided by 2.2 meter per second, then VB will be simply 1.8 meter per second. That's the answer for question number 14, matching with option 1. 15, question number. The velocity of water in a river is 2 kilometer. So this is the basically question number 15, and your river is 2 kilometer per hour. width of the river is 400 meter, and a boat is rowed from point, rowing always aiming opposite point at 8 kilometer per hour of still water velocity. So this is from here, this width is given and river velocity is given. Now it's mentioned the boat is rowed from point, rowing always aiming opposite point. So means the boat is moving like always, boat velocity is always maintained towards this opposite points. So this is v velocity of boat with respect to river. Okay, and this is mentioned as how much? 8 kilometer per hour. Then it's asking like on reaching the opposite bank drift obtained. So that we can write first time is equal to what? 400 divided by 8 kilometer per hour. Let me write it. Then this is the time taken. Then drift is equal to how much? Time multiplied by UR. And this is equal to 4 meter divided by 8 kilometer per hour multiplied by 2 kilometer per hour. So kilometer per hour simply gone. This is 4 and this comes out to be 100 meter. So this is the drift, and that's matching with option number 4, question number 15. Question number 16. Man can swim with the speed of 4 kilometer per hour in still water. So this is question number 16. Velocity of man in still water, it's 4 kilometer per hour. How long does he take to cross the river 1 kilometer wide? 1 kilometer wide is the width of river, and flowing steadily at 3 kilometer per hour. The river is 3 kilometer per hour, and it's he make his stroke normal to the river current. So means velocity of man with respect to river. So this is VMR is normal to the UR stroke, is it? And everything is given to us. Now it's asking how far down the, okay, first thing is how long he will take to cross the river, and how far down the river does he go when he reaches the other bank. Means it's talking about time to cross and drift. So time to cross will be simply equal to t is equal to what? 1 divided by velocity along this, that is equal to 4. That is this is in hour, that is 15 minute. And next thing is time drift. So drift will be equal to time, that is 1 by 5 hour multiplied by the velocity, that is 3, and this will be equal to in kilometer, that is 750 meter. So time to cross is 15 minute and drift will be 750 meter. This is answer for question number 16, which matches with option 1. Next, question number 17. Okay, question number 17. Cricket ball is hit for a 6, leaving the bat at an angle of 60 degree with the horizontal. So it's this is 60 degree cricket ball leaving for 6 with the 60 degree to the horizontal with kinetic energy K. So means speed is U, then I can write half mu square is equal to K. Okay, this is the information. Then kinetic energy at the top of the ball. So this is initial velocity, this is U cos 60 degree, this will be U sin 60 degree, and we know at top, this is the top point, this velocity will become 0, Vy will become only, this will be U cos 60 degree will be the velocity left. Then kinetic energy at the top, kinetic energy at top will be equal to what? Half m into u square cos square 60 degree, right? And this is half m u square, and this is equal to how much? K, and cos square 60 degree, cos 60 is equal to how much? It's 1 by 2 whole square, so that is equal to K by 4 is the answer for question number 17. Next, question number 18. From a point on the ground, a particle is projected with initial speed u such that its horizontal range is maximum. Horizontal range is maximum, that means theta of projection should be 45 degree. Okay, speed is u. All right, the magnitude of average velocity during its ascent. So means during its ascent, it's talking about, let's say this. So ascent, it's ascending up to here. So average velocity from here to there, then we need to get total like displacement, this plus this, and time taken. So time will be half of the time period. So time is equal to u 2u sine theta. So means u sine 45 divided by g is the time. So u by root 2 into g is the time. Okay, and half of range plus hi, maximum height, will be the displacement. I mean, the resultant of these two will be the displacement. So r is equal to how much? U square sine 2 theta by g. This is the, and this is equal to 1. So range is equal to u square by 2g. Basically this is half of r by 2, and h max is equal to u square sine square theta divided by 2g sine square theta. Now if I am substituting, this is u square and theta is equal to what? 45 degrees. So it's u square by 4g is the h max. Then what is the displacement? Displacement is equal to under root r by 2 whole square plus h square. So this is equal to under root u square by this r by 2 whole square. So u square by 4g square plus this u square by 16g square. So this is u square by 2g, and this is under root 5 divided by time, that is u by root 2g. So this is total displacement. Then v average will be s divided by time, that is equal to u square root 5 divided by 2g, not 2g, divided by, taking LCM, this is multiplied by 1 more 2, so it will be 4g divided by time is u by root 2 into g. This gets cancelled, and this is u, so 1 u gets cancelled. Then this v average is coming out to be root 2 into root 5 divided by u divided by this is 4. So that can be written as basically 2 root 2. This will be the average velocity that matches with option 1 for question number 18. Next, question number 19. The horizontal and vertical displacement of the projectile are given as x is equal to at and y is equal to bt minus ct square. So differentiation of this will give you ux, that is equal to a, and vy will be b minus 2ct, but velocity along y direction at t is equal to 0 will be your uy. So uy will be equal to b because substituting t is equal to 0. So then initial speed is equal to under root ux square plus uy square, that's coming out to be under root a square plus b square. This is initial speed. That's the answer to question number 19. Okay, next that is matching with option 1. Next, question number 20. Bird of mass 0.5 kg is rising vertically with the acceleration of 0.2 meter per second square. The muscular force exerted by it. So see, bird, I can just take it block. It's moving upward with 0.2 meter per second square acceleration, and it should be first maintaining its weight also. So muscle force should be sufficient, so that it should first counterbalance the weight and then provide additional force, so that this much is the acceleration. So like, let me write that force as F, then I can write F minus mg should be equal to m into a. So this comes out to be F is equal to mg plus a, right? So this is equal to 0.1 into g is 9.8 plus 0.2. So this is equal to what? 1 Newton. And then we can check the option. So it's 1 Newton. A, that's correct answer. B option is 9.8 kg weight. No, it's like basically equal to 1 by, I mean like kg weight means that kg multiplied by g should be the equal to. So it's like 1 by like 9.8 kg weight, that matches actually. So it's option is like A and C are correct, so that matches with option 3rd. Okay, so question number 20. Next, question number 21. Okay, next question number 21. Systems shown in the figure M1 greater than M2. So this is question number 21. This pulley, one spring and block M1 mass, another M2 and attached to this by string. This is mass M2. It's given M1 is greater than M2. Tension in this will be equal to, like say, T1. Here also it will be T1 and here it will be T2. So what I can write? T1 T1 will be equal to what? M1 into G, and T2 will be equal to, this is M1 minus M2 into G will be the T1, T2. Okay, so now what else? Like, system is held up at rest by the thread BC just after the thread BC is burned. So what will happen actually when this is burned means this is cut down. In this situation, there is a spring, and there is a special condition for spring. In a spring, the condition is that if it is connected like between two ends, it means two ends are connected and neither of the two ends are cut. In that situation, the tension in the spring does not change immediately. So that means even if I am cutting this, at this point tension T1 will remain same. Understanding? This implies this T1 will also remain same. So what will happen here? It becomes 0. So tension here will become how much? Upward force on this block will be like M1G, downward force M2G, so it will accelerate. Here tension T1 remaining same, so it, and downward force M1G also same, so it will have net force 0. So now according to that we can answer acceleration of M1 will be equal to 0. That's correct answer. Acceleration of M2 will be downward, no, it will be upward, and magnitude of acceleration of the two block will be non-zero, not definitely magnitude of acceleration of both the block, no, that's not correct. So only correct option is 1 in case of question number 21. Next is 22. A ball is suspended by a thread from the ceiling of the tram car. The brake are applied and the speed of the car changes uniformly from 36 km per hour to 0 in 5 seconds. So that means initial speed 36 km per hour, that is equal to 10 meter per second. Finally it's coming out to rest. So acceleration due to the brake is equal to 10 minus 0 divided by time taken 5 seconds, that is 2 meter per second square. This is the acceleration due to brake. And tram car, so this is tram car, so brake acceleration, let's say acceleration due to brake is this, and one mg is always acting downward. The angle by which the ball deviates from the vertical, so here if one ball is hanging like this, so it will, if nothing is there, then it will be like downward mg, but this force will try to pull it backward, so it will deviate by some angle along the net resultant force. So this will be ma, this downward force is mg. So angle theta, this is straightforward, tan theta will be equal to ma divided by mg, and mm gets cancelled, a is 2, g is 10, so this implies theta is equal to tan inverse of 1 by 5. This is answer to question number 22, that matches with option 3. Next question number 23. The elevator shown in the figure is descending with an acceleration of, so elevator shown in the figure is descending, means it's moving downward with acceleration 2 meter per second square. Okay, and this is block A, this is B block. The mass of the block A is 0.5 kg, MA is 0.5 kg. Okay, the force exerted by the block A on block B, so that we can calculate. This is block A, let's say downward force mg, upward force normal reaction, and its acceleration. Then what I can write, mg minus normal reaction is equal to ma, net force must be downward, net force is equal to ma. So normal reaction is coming out to be mg minus a is equal to normal reaction because it's descending downward. So then m is equal to 0.5, g is 10, minus a is 2, and this comes out to be 4 Newton. That is the answer. And this normal reaction between A and B will be the actual force applied by block A on B, and that answer is coming out to be 4 Newton. So which matches with option 2. Next question number 24. When a force F acts on the body of mass M, so question number 24. So F force is acting on the body of mass M, then acceleration produced is A. So acceleration, I can write A is equal to F divided by M. Now the situation is something different here. Here it's F2, it's F1 and F3. This angle is 135 degree, means this is equal to 45 degree. So it will have F3 by root 2 in this direction component, F3 by root 2 in this direction. So net force, it's also clearly mentioned F1, F2 and F3 equal to F act on the same body in the same plane as shown in the figure, then net acceleration produced. Remember it. So net acceleration in this direction will be this minus F3 by root 2. In this direction it will be F1 minus F3 by root 2. Because F1, F2, F3 are equal, so this I can write F1 minus, I can take it root 2 minus 1 by root 2. And here also it will be F root 2 minus 1 by root 2. So these are net force acting in y direction, z, x direction. Acceleration I can write divided by mass will be the acceleration ay, divided by mass will be the acceleration ax. So this is equal to how much? A. So I got ay is equal to a, this is under root 2 minus x by root 2, and ax is equal to a under root 2 minus 1 by root 2. So then ax, ay, then what is the net acceleration? And when these two are equal, then I can write a net is equal to what? Ax root 2, because ax and ay are equal in magnitude. So that means ax into root 2, so it gets cancelled. So we are getting net acceleration is equal to a root 2 minus 1. This is the answer to the problem number 24 that matches with option number 1. Okay, next question number 25. The apparent weight of a person inside a lift is W1 when the lift move up with certain acceleration. So person, and it's moving, let's say, with the acceleration up a, then let's say actual weight of the person is W. Then I will write apparent weight is equal to what? W1 is equal to, or I will write m into g effective, that is g minus a, in case when it's g plus a, or you can write W true plus ma. Next case when it's mentioned when lift move up with certain acceleration, and is W2 when lift move down with same acceleration W2, so that means it will be mg minus ma, that means W minus ma. Okay, the weight of the person when lift move up with constant speed. Constant speed means acceleration is equal to 0. What will be that weight? So that weight will be equal to what? W. So then from these two equations we need to calculate W. Then what we can do? Just simply adding these two, W1 plus W2, W1 plus W2 will be what? Here 2W, and this plus minus cancel out, so W actually is equal to W1 plus W2 divided by 2. This is the answer, and that will be the weight of the person when it's moving like standing in the lift moving with constant acceleration. That is question number 25. Option matching is 1. Next question number 26. The block is placed on a frictionless surface in gravity free space. A heavy string of mass m and is connected with the force connected, and a force F is applied on the string, then the tension in at the middle of the rope. So see it's also not much complex problem. This force F is applied and its mass is m. So first is acceleration of the system is how much? Total force divided by total mass, capital M plus small m. Now if I'm talking about tension at this point, then I can just simply remove. So this will be the tension. Then tension is equal to what? Mass into acceleration. Acceleration I already have. What is the mass of the system? That is m by 2. So I can write T is equal to mass is capital M plus small m by 2 multiplied by acceleration is this. So this is capital F divided by capital M plus small m, and this is the answer. That is the tension in the rope at midpoint. So which matches with option 1. Next question number 27. So here two masses m1 and m2 are attached to the spring balance as shown in the figure. If m1 is greater than m2, then the reading of the spring will be equal to, that reading will be simply equal to the tension, is it? And tension in this system when like two, you can treat it just like this is m1 m2. So in this situation the tension in the is 2 m1 m2 divided by m1 plus m2, so that m1 plus m2 into actually g, this will be the tension if it is weight, and that will be equal to the mass of this much. So according to the option we can check the option. So it's m1 minus m2. It's actually not talking about the force, is it? The weight, the reading of the spring balance, it's talking in terms of mass. So that reading will be equal to this weight, and that will be equal to this much mass. So it matches with option third, 2 m1 m2 divided by m1 plus m2. Consider the system shown in the figure. The pulley and the strings are light and all the surfaces are frictionless. The tension in the string. So question number 28. Here this, 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 and this. Is it? So now see what is happening here in this situation. Only one string and this is pulled horizontally. This is the only pulling force applied. So acceleration, this is mass, both 1 kg, and acceleration I can write pulling force, that is 1 into g divided by net mass to be pulled, that is 2. So we are getting it's 5 meter per second square is the acceleration. Now for this block, if I write free body diagram, the T is equal to what? Ma. So tension is coming out to be mass m into x. Acceleration is 5 meter per second square, so into acceleration 5, so tension we are getting it's 5 Newton. That's the answer, and that will be equal to option 4. Next question number 29. So two masses here, question number 29, this and this is being pulled with 150 Newton. This is 5 kg, this is 10 kg, right? This is the system. So two masses 10 kg and 5 kg are suspended from the rigid support as shown in the figure. The system is pulled down with a force 150 Newton attached to the lower mass. The string attached to the support breaks and the system accelerates downward. So this breaks and system accelerate downward. Then what will be the acceleration? The net force acting on the system is, one is this and another is its weight. So net force I can write will be equal to 150 plus 15g divided by total mass is 15, and that comes out to be 2g is the acceleration. Clear? Now it's talking about the string attached. Okay, then the system is pulled down with a, okay, in case the force continue to act, what will be the tension acting between the two masses? So tension acting between this T, so this T I can write acceleration, I got A is equal to 2g. So I can draw a free body diagram for any block. So it's T, it's mg and acceleration. So then I can write T plus mg. Mg is equal to how much? 10g is equal to acceleration mass 10 into acceleration 2g. So this implies T is equal to 100 Newton. That's the answer to question number 29. Next, question number 30. The acceleration of m1, m2 are a1 and a2 as shown in the figure, and then it's talking about the relation between acceleration. So it's let's say m1 pulley, this is the system connected, and here it's m2. Okay, now here tension is t, and here it will be 2t, and acceleration of its a2, acceleration here a1. So we know in this situation there is one shortcut method, that the relation between the acceleration is 2, so it will be 2a2 equal to a1 is the relation, which matches with option number 2. So that is the correct answer. Logic: if its acceleration is a2, acceleration a1, get the relation between their tensions. Let's say if tension on this block is nt and tension on this block is mt, then I will write ma1 equal to na2, means acceleration multiplied by the number of times tension, is it? N into t, tt both same, so then it's na, and here m is equal to what? 1, n is equal to 2, so that's what we are getting this relation. This is shortcut method actually in this problem that must have been taught when you are like Newton's laws of motion is discussed. So next, question number 31. Block of weight W is capped on rough horizontal surface, friction coefficient mu, the two forces each acting. So in this situation, like this is a block and forces W by 2 acting at an angle of 30 degree, another W by 2 acting downward, and its weight W will be also there, friction coefficient mu. So net upward, like I can write normal direction is equal to how? W plus W by 2 minus W by 2 into sine of 30 degree, that comes out to be W plus W by 4. This is 5 W by 4 is the normal direction. This force is equal to W by 2 into cos of 30 degree, that is equal to W root 3 by 4. So this is the pulling force. So if this is greater than the friction force, then only it will be able to move. So I can write root 3 W by 4 must be greater than mu into normal direction. Normal direction is W into 5, means 5 W by 4. So that means mu must be less than equal to root 3 by 5 for the block to move. That is the condition. Now rest we can check the options. for mu greater than root 3 by 5 block will move. No, for mu less than this block will move, so that first option is not correct. Second option, for mu less than this work done by friction force is 0. No, if mu is less than this it will move, then friction will act backward and work done by friction force must be negative actually. So second is also not right option. For mu greater than root 3 by 5 friction force will do positive work. If mu is greater than this, in that situation actually it will not move, friction will be higher. Fourth option, for mu less than work done by friction force is negative, so that will be the fourth option is actually correct here. For mu less than this, friction will be like acting backward, it will be moving forward, so work done by friction will be negative, and that's the correct option. Question number 32 here. A uniform chain of length capital L hang from partly from table which is kept in equilibrium by friction. The maximum length that can stand without slippage is L, then the coefficient of friction between the, so in this situation what is happening actually here, this is, let's say, a chain, the hanging part it's small l, total length is capital L, so this will be how this, if lambda is the linear mass density, then friction force acting on this part will be balancing this weight. This I can write lambda L into G is the pulling force, and if friction coefficient is mu, then I can write mu into its mass capital L minus small l into lambda into G. So now for the system to remain, I can write in equilibrium, this can be lambda L G, and this G gets cancelled, lambda gets cancelled, mu is coming out to be L capital L minus small l. This is the mu which matches with option third. Next question number 33. A ball is thrown vertically upward from the ground. Regarding the work done by air resistance, which of the following? First thing is resistance, so that means it will oppose the motion, that means it will be always opposite to the direction of motion. Okay, and if that is the condition, then work done by that force will be negative, because ball moving forward, force acting backward, so work done negative. So now what is happening, like when ball is thrown upward, then friction force will oppose that motion also, so it will act downward. When ball moving upward, work done by friction or work done by that air resistance will be negative. When ball is moving downward, what will happen? It will oppose its downward motion also, then it will act upward. In that situation, again work done by that resistance will be also negative. So based on that you can answer, work done is positive during ascent, negative during descent. No, work done is negative during ascent, negative during descent. Only fourth one is the correct option for question number 33. Fourth is the right option. Next question number, a particle is projected at t is equal to 0 from the point on the ground with a certain velocity at an angle theta with the horizontal, the power of gravitational force is plotted against time, that which of the following is best written. So in this situation, question number 34, I can write, it's u is the speed, theta is the angle, then velocity at t time can be written as u cos theta I cap, u sin theta minus gt j cap, and force is equal to mg minus j cap. Then power, what is the power? Power is equal to f bar dot v bar. This is the power. So this, if I am dot product, then it will be like 0, and it will be minus mg u sin theta plus mg square into t. This is the power, right? So this is some negative starting from here, slope is positive and straight line, so this will be the power versus time graph, which matches with option 3. Okay, so 34 question, and next question is 35. By applying the brake without causing skid, the driver of the car is able to stop his car in a distance of 5 meters. So question number 35, let's say the initial speed of the car is u, acceleration due to braking is a, and displacement in which it's finally bringing the car to rest. So initially it's given as 5 meter, right? So in this situation, what I can write, final velocity is becoming 0. So 0 minus u square is equal to 2 into a negative into 5. Okay, let's say in next case it's saying if it is going at 36 km per hour. 36 km per hour means u 36 km per hour is equal to 10 meter per second. So then I can substitute it, it will be equal to 0 minus 100, because 10 square. In next situation, it's when giving at 72 km per hour. So means u2 will be 72 72 kilometer per hour is equal to 20 meter per second. So this I can write, let me write it here. One relation I got this, another is final velocity 0 minus initial velocity 20 square is equal to minus 2 acceleration a into displacement s. Initially 0 minus 10 square is equal to minus 2 into acceleration a, and this is 5 meter. Just dividing it, simplifying it, we are getting s is equal to 4 times of 5, that is 20 meter is the answer, which matches with option number 3. So for 35, third is the correct option. Okay, next question number 36. A body of mass m is equal to 0.5 kg travel in a straight line with the velocity v is given by a x raised to power 3 by 2, where a is 5 meter power minus 1 by 2 into second inverse. What is the work done by the net force during its displacement from x equal to 0 to x equal to 2 meter? Work done it's asking actually. So first we need to create the force. Force means we need to first have acceleration. So differentiating it with respect to time, then I will get dv by dt is equal to a, and this is 3 by 2 x raised to power half into dx by dt, that will be equal to v, and v is equal to this. So substituting it, 3a by 2 into x raised to power 1 by 2 into a into x raised to power 3 by 2. I am getting basically it's 3a square by 2 into x square is the acceleration, and force is equal to mass into acceleration. Mass into acceleration, mass is 0.5. So let me write it simply mass. So force I am getting it's 3ma square by 2 into x square. Then what is the work done? dw is equal to f into dx, that will be equal to 3 ma square x square divided by 2 into dx, integrating it 0 to 2, 0 to w, and simplifying it, substituting all the values, we get it, solving it, 50 joule is the answer to question number 36. Next question number 37. Crane can lift up 100 kg of coal in 1 hour from a mine of 180 meter depth. If the efficiency of the crane is 80%, its input power, let's say input power is P, then 80% efficiency means 0.8 into P is equal to work done by the crane, is it? Or this power is equal to the power used in lifting. So power used is 1000 kg, 10,000 kg, 10,000. So mgh, m into g into h is 180 meter. This too, it's lifting in 1 hour, so I need to, so means 3600 second. So this is the power. So now 0.8, because if efficiency is only 80%, so p is the p input power, then I can write p input is equal to this complete divided by 0.8, basically this gone, and it's equal to 2. So this is equal to 10,000 divided by 2 multiplied by 0.8 multiplied by, this is taking, I like this is your final. So just simplifying it, basically it comes just simplifying it, p comes out to be 6.25 kilowatt, and that's the answer. Next question number 38. Spring when compressed by 4 centimeter has 2 joule of energy stored in it. So means x is equal to 4 centimeter. Okay, and then what it's asking actually, the force required to extend it by 8 centimeter. All right, so I can write 2 joule is equal to half k into x centimeters, 0.04 into 0.04, kx square is equal to 2 joule in SI unit. This implies k is equal to 2 multiplied by 2 divided by 0.04 into 0.04. This is k. Then force is equal to this k into x. So this is 4 divided by 0.04 into 0.04 multiplied by display, like expansion is how much, 8 centimeters. So that means 0.08. So this all decimal, 2 zeros, this is all gone. Now it's 414 gone, and this is 2. So we are getting it, force is equal to 200 Newton. That should be the answer, matching with option third. Next question number 39. A tank of mass 10 by 10 full of water and built on the ground If G is 10 meter per second square, the potential energy of this water stored. So first thing is, this is a tank, okay, full up to 10 meter height and 10 meter base and everything is there. So first, what is the mass? Mass is equal to density into volume. Density is 1000 multiplied by volume is 10 into 10 into 10. So this is 10 raised to power 6 is the kg is the mass. Then m, g into center of mass will be at height h by 2. H by 2 means 10 by 2. So this is the potential energy. So we are getting it 5, nearly 5 into 10 raised to power 7. This joule is the potential energy of this system for question number 39, which is matching with option 1. Question number 40. A cradle is h meter above the ground at the lowest position. So cradle, it's sort of like this is from h meter above. When it's at lowest position, then it's h meter above, and it's having some speed. Basically, v will be the maximum speed. Alright, so and h meter, capital H, when it is at the highest point. So when it's at highest point here, then it's capital H meter above. If v is the maximum speed of the swing of the total mass m and the relation between g and h and all that, so v is the maximum speed, means maximum speed will be where? At lowest position. So then I can write at this point total energy is m v square by 2 plus mgh, and at top it will be equal to mg into h. Total energy, it will be converted into like potential energy. Just dividing by mg, we are getting it's basically v square by 2g plus small h is equal to capital H. This is the relation which is matching with option number 2. This is question number 40. Okay, next question number 41. So here, a particle of mass of the particle is 0.5 kg is the mass of the particle, is displaced from position initial r1 2, 3, 1 to r2 4, 3, 2 by applying a force of magnitude. So first, displacement s is equal to how much? R2 minus r1, I am writing it directly, 2 I cap plus 3 minus 3 0 j cap plus 2 minus 1, it's k cap. So this is the displacement, and force is 30 Newton. So and direction is given I plus j plus k, so that can be written as 30 by root 3 into I plus j plus k. Then what is the work done? Work done is equal to force F bar dot S bar. F dot S, it's coming out to be W is equal to, it's 60 plus 30 divided by root 3, that is equal to 30 root 3 joule is the work done, matching with option 2. Question number 42. Block of mass 2 kg is initially at rest on horizontal frictionless surface. Horizontal force of this Newton act on it when the block is at x is equal to 0. Alright, the maximum kinetic energy of the block initially at rest. So force acting is 9 minus x square. This is the I cap force acting, and initially it was at rest, and it is also given it is at rest at x is equal to 0. So means there it is at rest. Then the maximum kinetic energy, so I can write this is the force, is it, divided by mass will be the acceleration. So 9 minus x square by m is equal to what? V dv by dx. Simply integrating it, then I will get what? Initially it is given x is equal to 0, it is at rest, so this implies v square by 2. Initial velocity is also 0. Directly integrating it, we are getting it 9x minus x cube by 3 divided by m is the velocity, 9 this 1 by m. Okay, so we got velocity. Now it's saying it's talking about, okay, the maximum kinetic energy of the block between x is equal to 0 to x is equal to 9. So it will be where velocity is maximum. For velocity to be maximum, I can simply differentiate it, then I will be getting it simply v, this is for v max. So this is 2v by 2 into v prime is equal to 1 by m into 9 minus x square equal to 0. This implies x is equal to 3. So I can get at x is equal to 3, velocity will be maximum. Substituting here x is equal to 3, it will be 27 minus 9, so that comes out to be 18. So the maximum kinetic energy is half mv square, and that's coming out to be simply 18. Simplifying it, that is the correct option, matches with option 3. Question number 43. A block of mass 25 kg on a smooth horizontal surface with a velocity of 3 meter per second meet the spring of the spring constant k is equal to 100 Newton per meter fixed at one end as shown in the figure. The maximum compression of the spring and the velocity of block as it returned to the original. So simply here what is happening, the kinetic energy of block will get converted into the potential energy of the spring. So kinetic energy is given as half m is given as how much, 25 into velocity is 3 square equal to m, like means half k is 100 into x square, right? So half gets cancelled and x is coming out to be 5 into 3 divided by 10, that is 1.5 meter will be the compression, maximum compression. And when it's returning back, then what will happen? Because no loss of energy is taking place, so velocity will be exactly same once it is leaving the spring, and but direction will be opposite, so it will be minus 3 meter per second square. So one option, 1.5 meter maximum compression minus 3 meter per second is the velocity, is the right answer. Question number 44. A pump is required to lift 600 kg of water per minute from a well of 25 meter deep and to eject it with a speed of 50 meter per second. The power required to perform the above task. So means pump is lifting the water from a deep of like 25 meter deep well. So mgh work done plus it's pumping with the speed some v, so then half mv squared. Right, if I am taking, let's say m is the mass, it's given even 600 kg weight is lifted in 60 seconds. So I will get per minute, so that means 60 seconds. So I will get total work done by the pump divided by time taken will be the power supplied or power of the pump required. So that will be equal to power is equal to mg into h plus half m into v square and divided by time taken is 60 seconds. So here m is 600, g 10, h is given as how much, 25 meter deep well plus half into again 600 into v square, how much is speed, 50 meter per second square, 50 square, this divided by 60. Just we can simplify it further and solving we will get it comes out to 15 kilowatt. This is the answer for problem number 44, matches with option 2. Just simplifying it, we will get 15 kilowatt. And the last 45 question number. Human heart discharges 75 centimeter cube of blood per beat against an average pressure of 10 centimeter of Hg. Assuming that pulse frequency is 75 beats per minute, the power of the heart is, okay. So now here I can write, see, pressure is equal to rho g Hg, because rho into rho g h, and that's given as rho is 13.6 into 10 to the power 3 into g is 10 and h is equal to how much, 10 centimeters, so it means 0.1. So this is the pressure. Now power is equal to, so pressure multiplied by area will be the force, and force multiplied by, let's say if it's displacing x, then it will be the work done, and divided by t, then x by t will be your velocity. So I can write the power is equal to pressure multiplied by area into velocity, that is your volume flow rate, is it? So this comes out to be, actually it's pumping 75 centimeter cube of blood, so volume is equal to 75 centimeter cube, that is equal to 75 into 10 to the power minus 6 meter cube in SI unit, okay. And it's like in 1 minute 75 beats are there, so total it's, this is the volume of 1 beat. So volume in 1 minute, that I can write 75 into 75 into 10 to the power minus 6 per second, that is volume flow rate time. So this is 75 into 75 into 10 to the power minus 6 divided by 60. Then power is equal to simply pressure multiplied by volume flow rate. So this is 13.6 into 10 to the power 10 to the power 3 into 10 into 0.1 will be 1 into 75 into 75 into 10 to the power minus 6 divided by 60. Again simplifying it, we get it something 1.25 watt. This is the answer to question number 45. So this is all about all the problem. Thank you so much.